The periodic table is fundamental in various fields and has several real-life applications. Chemistry. It's the basis for understanding chemical elements, their properties, behaviors, and their interactions. Elements like carbon, hydrogen, oxygen, and nitrogen are crucial in organic chemistry, affecting everything from medicine to materials science. Materials science. Engineers and scientists use the periodic table to design new materials with specific properties. For instance, creating alloys for construction or electronics by combining elements based on their atomic structures. Medicine. Radioactive isotopes of elements like iodine, technetium, and cobalt are used in medical imaging and treatments, such as CT scans, MRIs, and cancer therapies. Technology. Electronics heavily rely on elements like silicon, copper, and gold. The arrangement of elements in the periodic table helps in designing circuits, semiconductors, and other electronic components. Environmental science. Understanding elements and their compounds aids in studying environmental pollution, tracking elements in ecosystems, and developing solutions for waste management. Energy production. Elements like uranium, thorium, and hydrogen are crucial in nuclear reactions and alternative energy sources, such as nuclear power and fuel cells. Agriculture. Knowledge of elements and their compounds helps in developing fertilizers and understanding soil composition, ensuring better crop yields. Forensics. The analysis of trace elements found in various materials can assist in criminal investigations and determining the origins of substances. Medicine. Technetium-99 meters, a radioactive isotope, is extensively used in medical imaging, particularly in single-photon emission computed tomography scans. This isotope is created from molybdenum-99, which has a relatively short half-life and decays into technetium-99 meters, allowing for safer diagnostic imaging procedures. Electronics. Silicon, a key element in the semiconductor industry, forms the basis of computer chips and integrated circuits due to its unique electrical properties. The periodic table's organization helps engineers design and develop specific components by combining elements like silicon, germanium, and gallium to create electronic devices. Agriculture. Phosphorus, an element found in the periodic table, is a primary component of fertilizers. Understanding its properties and abundance helps in developing fertilizers to enrich soil and promote plant growth, thereby enhancing agricultural productivity. Environmental science. Mercury, a heavy metal, is found in various compounds and can contaminate ecosystems. Knowledge of its properties and behavior from the periodic table assists scientists in monitoring and managing mercury pollution, safeguarding environmental health. Materials science. Steel, an alloy predominantly made of iron and carbon, demonstrates different properties based on its composition. By combining elements from different groups of the periodic table, engineers create materials tailored for specific uses, such as stainless steel for corrosion resistance or high-strength alloys for aerospace applications. Nuclear energy. Uranium-235, a radioactive isotope, undergoes fission reactions to produce energy in nuclear power plants. The periodic table's arrangement helps in understanding elements suitable for nuclear reactions and fuel production. Water purification. Chlorine, a halogen element from the periodic table, is commonly used in water purification systems to disinfect and kill bacteria, making drinking water safe for consumption. Photography. Silver compounds derived from the element silver are used in traditional film photography. When exposed to light, silver halides undergo a chemical reaction that forms an image on photographic film. Battery technology. Lithium, found in Group 1 of the periodic table, is a crucial element in rechargeable lithium-ion batteries due to its ability to store and release electrical energy efficiently. These batteries power a wide range of devices, from smartphones to electric vehicles. Catalysis. Platinum and palladium, both transition metals, serve as catalysts in various chemical reactions. They enable reactions in industries such as petroleum refining, vehicle exhaust control systems, and the production of pharmaceuticals. Food industry. Salt, sodium chloride, is a vital compound derived from elements in the periodic table. It is used not only for flavoring but also for food preservation and enhancing texture in various food products. Fireworks. Different metal salts derived from elements such as strontium, lithium, and copper, when burned, emit distinct colors in fireworks displays. This is due to the specific wavelengths of light produced by the excitation of electrons in these elements. Glassmaking. Silicon dioxide, derived from silicon and oxygen, is the primary component of glass. Various other elements from the periodic table are added to produce different types of glass with specific properties. Like boron for heat resistance or lead for increased clarity in crystal glassware. Cosmetics and pigments. Titanium dioxide, a compound derived from titanium, is extensively used in cosmetics, sunscreen, and paints due to its ability to provide white pigment and UV protection. Airbags in vehicles. Sodium azide, derived from sodium, is employed in the production of airbags. When a collision occurs, this compound decomposes rapidly to produce nitrogen gas, which inflates the airbag, protecting occupants in vehicles. Steel production. Manganese, found in Group 7 of the periodic table, is added to steel to enhance its strength and resistance to wear and tear. This improves the durability of steel used in construction, machinery, and transportation. Photovoltaic cells. Solar panels use elements like silicon and various other semiconductors derived from the periodic table to convert sunlight into electricity through photovoltaic cells. Fluorescent lighting. Phosphors, containing elements like europium, yttrium, and terbium, are used in fluorescent lights. These elements emit visible light when excited by ultraviolet radiation, contributing to the illumination produced by such lights. Space exploration. Rockets and spacecraft rely on elements such as aluminum and titanium for their lightweight yet strong properties. These materials enable the construction of spacecraft that can endure the harsh conditions of space travel. Textiles and fabrics. Elements like copper and zinc are utilized in the production of antimicrobial textiles. These elements inhibit the growth of bacteria, providing hygiene benefits in clothing, medical textiles, and household items. Glass reinforcement. Boron compounds, derived from the element boron, are added to certain types of glass to increase their strength and thermal resistance. These glasses are used in laboratory equipment, cookware, and some types of fiberglass. Fire protection. Compounds containing phosphorus, such as ammonium phosphate, are used in flame retardants to reduce the flammability of various materials, including textiles, plastics, and construction materials. Dental care. Fluorine, a halogen element, is incorporated into toothpaste and drinking water to strengthen tooth enamel and prevent tooth decay. Metallurgy and alloy development. Nickel, chromium, and other elements from the periodic table are used to produce stainless steel, a corrosion-resistant alloy extensively utilized in kitchen appliances, medical instruments, and construction. Carbon dating. Carbon-14, an isotope of carbon, is employed in archaeological and geological studies to estimate the age of organic materials by measuring its decay rate. Art conservation. Copper compounds, such as copper carbonate hydroxide, have been historically used as pigments in paintings. Understanding the properties of these elements aids in the restoration and preservation of artworks. Industrial catalysts. Ruthenium, rhodium, and other transition metals serve as catalysts in various industrial processes, including chemical manufacturing and the production of synthetic materials. Water treatment. Aluminum sulfate, derived from the element aluminum, is used in water treatment plants to remove impurities by causing suspended particles to clump together, making them easier to filter out. Pharmaceuticals. Many drugs are formulated based on the properties of elements and their compounds from the periodic table. Elements like carbon, hydrogen, nitrogen, and oxygen form the backbone of numerous pharmaceutical compounds. Nanotechnology. Elements like gold and silver nanoparticles are utilized in nanotechnology applications, ranging from medical diagnostics and drug delivery systems to electronics and catalysis. Due to their unique properties at the nanoscale. Manufacturing. Elements like iron, aluminum, and copper are crucial in manufacturing processes. Iron is used in the production of steel for construction, transportation, and machinery. Aluminum is employed in manufacturing aircraft, packaging, and electronics due to its lightweight and corrosion-resistant properties. Copper is used in electrical wiring and plumbing systems due to its excellent conductivity. Cosmetics and skincare. Zinc oxide, derived from the element zinc, is used in sunscreen lotions and ointments to protect the skin from harmful UV rays. Zinc's reflective properties help to block and scatter UV radiation, providing effective sun protection. Air conditioning and refrigeration. Freon, a compound containing chlorine, fluorine, and carbon atoms, was historically used as a refrigerant in air conditioning systems and refrigerators due to its low boiling point. However, due to its adverse environmental impact, newer, more environmentally friendly refrigerants are now in use. Smelting and extraction. The extraction of metals from ores, such as iron from iron ore, copper from copper sulfide ores, or aluminum from bauxite, relies on chemical processes guided by the periodic table's knowledge to obtain pure metals for industrial applications. Pharmaceutical chemistry. Elements like sulfur, nitrogen, and fluorine are instrumental in the synthesis of pharmaceuticals. Understanding their reactivity and bonding patterns helps chemists design molecules with specific therapeutic effects. Food packaging. Oxygen scavengers, often composed of iron powder or compounds, are incorporated into some food packaging materials to absorb excess oxygen, prolonging the shelf life of products by preventing oxidation. Construction materials. Elements like calcium, derived from compounds like calcium carbonate, are used in the production of cement and concrete. Calcium compounds contribute to the strength and durability of these construction materials. Automobiles. Platinum and palladium, elements from the platinum group metals, are used as catalysts in catalytic converters to convert harmful pollutants in vehicle exhaust gases into less harmful substances, reducing air pollution. Artificial lighting. Tungsten, found in incandescent light bulbs, is used as a filament due to its high melting point and resistance to heat. LED lights also utilize elements like gallium, indium, and phosphorus for producing various colors and wavelengths. Forensic science. Elements like strontium and lead isotopes can be used to trace the origin of materials, aiding in criminal investigations and identifying geographical sources of substances found at crime scenes.